Hello and welcome to the AI Revolution with Cody Willard, Bryce Smith, and John Dio. Can I say your real name?
Sure, D'Oliveira.
John Dio Oliveira.
Oh, can you say it? I don't know.
Yeah, well, yeah, I might not pronounce it correctly. We were going to have Jensen Wong on tonight's call, but he's doing a keynote at NVIDIA's GCT. So maybe next week we'll have Jensen.
He sends his apologies.
Yeah. He says hi, everybody. Look, what we like to do here with John every week to just sort of give a brief intro to people who might be new tuning in or whatever. I'm a hedge fund manager. Bryce is a partner here, an analyst and CFO, I guess. I don't know. He helps me run the hedge fund, and we're always trying to figure out how to invest in the next great $1 trillion revolution. We've been writing and talking about the AI revolution for years now. We've been investors in NVIDIA personally for 8 years, in the vision that maybe one day they would be a real AI company. I certainly won't take credit for having foreseen their complete and utter dominance in the AI revolution. John Dio has been working in the AI revolution, in the AI industry before it was a revolution, as it was a burgeoning idea that maybe one day people would be able to talk to computers and you might not be able to tell it was a computer. But what's happened in the last 2 years, John, correct me if I'm wrong, is we went from incremental improvements, getting along, figuring out that we'll probably do this type of AI and these are what chips that might be needed and this type of software needs to be built, to suddenly, driven by NVIDIA, watching their GCT presentation. Jensen Wong was just, he's doing a 2-hour keynote and we're going to miss the last half. I'll have to go back. Bryce and I'll go back and watch the last hour of this later. But picturing what they're saying, what they're doing, and him pulling out actual modules of chipsets and how their new Blackwell platform is not going to use the old Hopper chips, but they got the new chips that are 2 different GPU chips connected. John, it's gone hockey stick. It's gone exponential. He was just talking about how the Moore's law, which states that computer technology doubles every 2 years. In every 5 years, it's a 10-fold improvement. In 8 years, they've just done 1,000 times improvement on what their AI chips were doing 8 years ago. And it's happening. And correct me if I'm wrong, NVIDIA's driving this, John.
Well, I don't want to correct you, but no, I would just say NVIDIA's driving the hardware aspect of this. And they're certainly very involved in the software side as well. And maybe it couldn't have happened without them. But I think the transformer and the uses of the transformer have been key, and that was invented ironically at Google.
Right.
But then, like I'd say, perfected so far with what OpenAI is doing. But they're all depending on NVIDIA.
John, but did Google invent the transformer, or did they buy it with DeepMind and the guys at DeepMind then?
They invented it. My understanding is it's not even a DeepMind thing.
Okay.
Transformer is a Google thing. Now, like the first use of the transformer was with BERT, BERT. And we were using that 2 companies ago where I was. And it was more focused around the notion of what they call embeddings, but it lets you do semantic search and things like this, find things in a much more intelligent way. It certainly wasn't the whole large language model thing, but it was the beginnings. It's the architecture that did BERT is the same architecture that does like ChatGPT, just scaled way up. And what allowed it to scale up was NVIDIA.
I preferred Ernie, but Bryce, you had a question?
There is an Ernie as well.
I do think in the emails that got leaked a couple of weeks ago regarding the the Elon Musk and OpenAI lawsuit, in those emails, Ilya Sutskever, one of the founders, said, look, what's changed in the last 2 decades isn't as much the algorithms as it is the computing power. And I think the invention of the transformer is big, but deep learning, I think, was an old form of AI that had a huge resurgence with the transformer, and then now NVIDIA's chips.
Yeah. So if you look at, and I'm going to say it was around 2008, but it might have been a little later when the deep learning stuff started doing that great demo with was it the NIST data set or something? So it was like handwritten numerals 0 to 9, and it being able to recognize, now that's a 3, now that's a 2, and where it just had a burst where it got like really good at that. And what at the time looked like, wow, big improvement. That big improvement wouldn't even show up as a little flea bump on compared to what's happened since.
Yeah.
That was the biggest kind of bump at the time.
And that seems to be, again, like we've followed and been active investors in NVIDIA for years, but watching the presentation today from Huang, he's taken it. I mean, I've seen presentations from him in the past and they're exciting, but nothing quite like the leap forward that they seem to be making on an exponential basis from one generation of GPUs to the next over the last 2 to 3 years. Now, John, one of the things that Bryce and I have been hard at work on, and I guess I'll actually share this real quick, is the AI stack. I think you and Bryce talked a little bit about this last week with the idea that what we're trying to do is put together what we call the AI technology stack, which you can do that in any industry. Where I originally learned to do this was in telecom, and you would take someone's computer and you'd show how it would connect to a Wi-Fi router that would then go through a DSL connection, copper wire to a DSL box in a co-located neighborhood that would then ship it over to a data center that would then really route it out to the internet, and then you could watch your Netflix, or at the time you would talk on the phone, really. But these days we've leapt forward and we're looking at how AI works. So at the very baseline level, silicon, which is what NVIDIA does, they take sand in the silicon in the form of sand, basically, and run it through lithographic machinery to these giant chip factory equipment that's made by the likes of ASML, Applied Materials, Lam Research, the like. They make these chips that are, silicon chips. That's the same sort of thing. But Apple, NVIDIA, Intel, AMD, Qualcomm, Avago, these guys all design the chips. The actual manufacturing of those chips, but dominated by Taiwan Semiconductor, Intel, and again, they buy the equipment from ASML, AMAT, Lam Research, KLAC, Teradyne. Samsung makes the chips also, but people in the West don't seem to trust the Samsung Corporation because Samsung has a history of stealing IP, intellectual property. The point being, John, down here is silicon. Then you put that silicon into the servers and you build data centers. And the people who make the servers, the companies that make the servers are Dell, Hewlett Packard, Super Microcomputer, IBM, etc. The data centers themselves are run and owned by the likes of Google, and data center / cloud, run by these guys that actually make it. And then they sell those services along the way. You've got data from the likes of Apple, Google, Microsoft, Twitter, Meta, Facebook. Then you're running. What I'm trying to get to with all of this is give, a brief introduction of how this stacks up upon itself. Great job on this, Bryce. But what's been interesting and what we've really been talking a lot about lately is, and now we started this question out, the AI revolution is being accelerated because of silicon capabilities. And meanwhile, I get an email from Anthropic today, and they're like, hey, we just updated some stuff. Check it out. We can now read pictures, which is what you were just talking about, that DeepMind could do 10 years ago. It could tell that an image of the letter of the number 3 was the actual number 3. Nowadays, you can, and we did, we upload this this graphic to Anthropic. We can upload it to Gemini, to Grok, which is Twitter's AI. We can do it to ChatGPT. We run it through all these different things, and they can read it. But what's been amazing, John, and where I'm getting at with all of this is over the last year and a half, the LLMs, the large language models that can read this graph, the websites that I can go to and upload this image and ask it to tell me about it, is starting to proliferate. It was just ChatGPT a year and a half ago. Now I can do it on 5 different places, and they all work great. Meta's giving away large language model capabilities so that, because I'm not thinking, what we're getting at is, doesn't look like the value lies in the large language models. The secret sauce, the real edge, the value that can't be replicated is in the silicon layer. That's why NVIDIA is able to charge $40,000 a chip a year and a half into this, while ChatGPT suddenly has 6 competitors.
I don't know. I want to challenge that slightly, which is to say, yeah, it's definitely dependent on NVIDIA and the speed of the hardware and so forth. I don't know. I mean, always the case with silicon is that your moat is your lead time, because it takes so long to try to go and like do what they're doing. I don't like, if some company like Grok, not the Twitter XAI Grok, but the Grok with I think with a K instead of a Q.
The silicon Grok is GROQ,
right?
And
right.
Twitter's AI large language model that we are arguing is getting commoditized quickly is GROK.
Yeah. So the silicon one, they may be onto something that'll do, it looks like, pretty fast performance like NVIDIA. Good luck scaling up to the NVIDIA level. But it's just to say that if they can do it, there's others who can go look at it and go, now that we know what that language model and other similar AIs, the generative AI stuff is, depending on for its calculations, which is very much matrix math. And the NVIDIA stuff originally was made more for computer graphics, and it just happened to use matrix math, and it was like, well, nothing else does. So look how well it works for AI when it isn't even built for AI. Now they're making it where it's built for AI. And I'm not putting down NVIDIA, and they do own the world, but I'm saying like I'm not sure I would put all the inventiveness there. There's inventiveness, not just LLMs. Yes, they're starting to get sort of commoditized, but there's another layer above those with the agents and the agent frameworks and things, which is, okay, so that's what LLMs do. What can you do with them? So like there's a thing that came out, I saw a paper last week called Quiet Star. And I was like, wait a second, is this Q Star? Because back, and I don't know yet the answer to that, but back when Sam Altman was getting kicked out of OpenAI, and there was big talk about internally they've got AGI, which I don't believe they do. But it was like, they've discovered this thing, it's amazing. It's Q Star. And from what I heard about it, it's not what this new, but then I heard about this new thing. I'm like, this is a Q Star, but it's Quiet Star, and the star stands for something. And if I just give me 1 second on this, it's like, while language models are essentially in that, Daniel Kahneman's book, Thinking Fast and Slow, they're just thinking fast. They're not able to like think about how they're thinking. They're just like, I'm going to spit out letters and words, and it'll start acting more and more intelligent. What Quiet Star is doing is, into that same process, it's inserting stuff that it doesn't say, which is a little bit of thought before it goes and gives its next token or whatever. And then it figures out, once the tokens turned out to be like, oh, that was good, I said something smart there, it can reflect back and go, what was I thinking at the time? And so we're seeing new things happen there that aren't apparent yet. in just language models being out there. That's another huge aspect here. So like, I just think it's oversimplifying.
That's partly going to happen because the large language model companies like Grok and ChatGPT have to differentiate themselves. They have to come up with something, that some sort of secret sauces that the other guys are not doing. And
well, also because
that's what makes capitalism so great at innovation, is those large language model companies have no choice but to figure out ways to differentiate themselves, and quickly.
But the differentiation that they're going for is AGI. I mean, it's not like, oh, I just, this seems kind of cool and other people don't have it, let's do this. It's like, no, it better work and it better be smart. But the other thing that does relate to NVIDIA about this is this new stuff that they're inserting is even more compute intensive. It's like before we were, going through and at least, kind of spit it out quick, whatever you can, and use these fast chips to help. And now it's like spit it out, but not as quick, because you got thinking that has to get inserted in between. So now it's even more reliant on the
silicon layer itself. Yeah.
I think one of the things that's most impressive about what NVIDIA is doing, and it's not just NVIDIA, but it's part of the whole chip design ecosystem. It's Ansys, Synopsys, and Cadence are the three that they just called out. But those are the software vendors that help chip companies design the chips, right? They make electronic design automation software, EDA. Those three companies are building software models on NVIDIA's like H100s, right? And then the H100s help those software companies become more powerful software, right? Which helps the next generation of chips, which they just unveiled, is Blackwell.
It's people.
Right? And Blackwell is 50x improvement on the H200, which was used to build Blackwell, right? So it's the machine building the machine. And I do think that's we're going to see some exponential increase that we've never seen before because of that kind of stuff happening.
There's a reference there to cannibalism. It's the old Soylent Green from the 70s, where they realize that they're eating people. So this is the computers are making the computers.
It is.
Soylent Green is people. NVIDIA's chips are NVIDIA's chips design chips.
But
you got it. Yeah.
that's where I think it really goes exponential. And we've been talking about the Kurzweil rate of change, and so we're seeing it in action.
I need to throw out a couple of definitions. AGI is artificial general intelligence. It's the idea that these large language models, or whatever comes next after those large language models, will be smart enough to be not just human beings, but probably be as smart as the entire race of human beings. Because by the time
that's ASI, right?
ASI, but by the time you get to AGI, how far is ASI, John?
Yeah, not far. So now you know what they used to call AGI?
Oh, it was, you just had to be able to be fooled. You had
the original name for AGI was AI.
Yeah. So now we have AI is here, so we have to differentiate AI from AGI, which is differentiated from ASI.
And the AI that's here used to be called ANI, which is artificial narrow intelligence, but now it's just not so narrow, is it? So they had to come up with something else.
Yeah. And then let's see, what's the other thing I was going to I lost the other definition I was going to. John, one of the other things you talked about on here today was we've spent the last 30 years of internet retrieving data and content. Might be a blog post, it might be an image, it might be a Netflix movie. But that movie, image, or content blog post is created somewhere and then stored, and then your computer or your phone, you type in a command or you speak a command to it, and it goes through that internet, takes that image, video, or blog post, chops it into an infinite number of tiny little pieces, sends it through the wiring system or maybe the satellite system or both, all ends up back on your computer, and somehow some pieces of sand that were turned into chips are going to read all that. That's electrons being transmitted, and we watch a movie and you get that content. What's happening now, he hit on this, and it was a key point, I thought. Bryce and I both sort of discussed it afterward. It's generation of that. It's going to be the generating. You're going to generate that content instead of retrieve that content. The AI, if you're, instead of going to YouTube and saying, hey, how do I fix the heater on thermostat thingy on my wall that's not working, you're going to FaceTime AI and ask it how to do it, and it's going to generate a
Specific
video,
thing, right?
a specific video for your request.
This is a hard thing to divide in that way, or determine to be that the way that we break it down, because remember that the web started in 1992 or something, I don't know, and around the turn of the century we had Web 2.0, and Web 2.0 was defined by user generated content. So it was about, you're going to actually make the stuff. And so when you talk about blogs, and people make blogs, you talk about YouTube, people push up YouTube videos. So like, yeah, over time it became like the creator class rather than just like everybody going and doing it. But the democratization of creation and so forth happened in 20 years ago in Web 2.0. So now we're having maybe the democratization of like at a new level with the intelligent stuff, or democratization of the use of intelligence to do this stuff, to really like, now I'm going to literally make my own movie. Okay. It's like, so there's something going on for sure. And definitely back to what you were saying earlier, we're on the hockey stick. And the thing about the hockey stick too, is it looks like a hockey stick. And then once you get onto the hockey stick part of it, it looks like a hockey stick.
Oh,
it's like it's more and more of a hockey stick to a hockey stick. So it's like,
but that was the other thing I wanted to define: the Kurzweilian rate of acceleration of change. And that is this concept that Ray Kurzweil, he was on Joe Rogan a couple of weeks ago. I didn't watch the whole interview. I've never seen Joe Rogan interview anybody in my entire life, but he was on there a couple of weeks ago, and then I saw a great clip where he was explaining how compute per dollar has gone on a straight, it's logarithmic, but it is a straight logarithmic line that is basically exponential growth, consistent over 100 years.
I think you said 80.
80 years.
Yeah.
So like basically since 1945, that's what it was, the end of World War II through today, 80 years. And it has been consistent. And interestingly, AI is sort of like keeps that on that logarithmic straight scale. But the idea is what Ray Kurzweil's what his biggest impact in my life was, and changed a lot of my thinking. And I was already a big believer in revolutions, technology revolutions, making the world a better place and creating trillions of dollars of value for the world. And what he talks about is how the innovation itself accelerates. So over the first 100,000 years, call it the first 6 million years of human beings being around, we invented the wheel and fire. And then somewhere 5,000 or 7,000 years ago, we started doing writing. And then somewhere within 100 years ago, we started actually making high rises. And now we're sending Starship rockets the size of high rises into outer space. And it's constantly accelerating. And so, that idea is carried over into AI, and it's happening right now for all of us. And what's interesting about both the internet and AI is their real world impact is also happening, I think, quicker than most of us thought was possible. Even as believers in the AI revolution, the speed with which ChatGPT a year ago I could say, hey, put Cody Willard as a guest in a Seinfeld episode, and it knew enough about me, and it certainly knew enough about Seinfeld episodes, it could create a content for it. Now, you can tell it to make an image of me in a Seinfeld episode, and it can do it. And somewhere in the next 2 to 3 years or so, John, we are going to be able to just tell it to, hey, write, maybe because of copyright reasons, it won't be a Seinfeld episode, but make a Seinfeld-like episode with characters like those in Seinfeld, and put Cody Willard, his real image, into as a guest appearance. And that's happening.
You just, I wonder, just as you were mentioning it, I was thinking, it becomes a new actually distribution channel for like the people who made Seinfeld. So they're oh, I'm going to sell this to rights to Netflix and so forth, and then they'll sell their rights to letting you actually do it with Seinfeld.
Yeah, I agree with that.
Yeah, that's another. It's one of the amazing things about life in the United States, where we actually enforce copyright and intellectual property laws. That if you make great intellectual property like Mickey Mouse, you can really get a lot of leverage out of that for 70 or 80 years until your true copyright ends, and they keep extending the copyright laws for those guys anyway.
Yeah,
well, it just did end for him. Yeah.
I think a lot of people have been concerned with the content creators and like them losing out to generative AI. But I think as humans, we tend to go back to those characters and songs and movies that we know and love. And I think Gen AI is going to expand that rather than destroy all, the content that Disney and Netflix and everybody has spent billions of dollars creating.
Yeah, that's interesting, right? Like instead of being the average guy at home being able to compete with Netflix, instead Netflix is able to make 100 times more amount of great quality content and get it distributed up through their app to your television or your smartphone.
When I see like a commercial on TV and it's got a Bob Dylan song in it, and I'm like, that was never going to happen. And then it happens. It's like, yeah, it's going to always move into these other areas. And then Netflix, we were talking about like, how are they going to do with Sora and all of this? And it's like, yeah, they could go license the stuff and show it, but do we continue to see shifts also in just how distribution happens, and whether it's this, I want some instantaneous stuff, and do they get sufficiently on that bandwagon to be the ones, or, do they get disrupted? I don't know.
That's right. That's right. John, another thing that Bryce pointed out when we were watching the NVIDIA power conference today was Jensen was pulling out their latest and greatest supercomputer, and it looked like a mainframe. And Bryce was like, so are you telling me the big computer PC revolution was taking mainframe technology and putting it in a personal computing device and
get as small as possible,
and eventually to fitting a super MacBook, what did I used to call it? A MacBook Pro in your pocket. And that's what I used to think eventually we would have. And that became the iPhone. But now we've gone from mainframes to the PCs, and now we're going to put mainframes to run all of our AI stuff again. So I'm picturing, work with me, that we want to hear you talk about mainframe to PC, and are we actually doing this mainframe back to mainframe transition? But the next thought was, so if I'm going to have my super smart glasses thing from Google, Visor Pro from Apple, whatever it is, and it's going to have a 1 gigabit connection to my Starlink Wi-Fi up in the sky, why aren't we just going to put this AI mainframe supercomputers up in low Earth orbit? Cloudflare, somebody connects it to the Starlink system, and the Starlink system doesn't even have to beam the stuff back to planet Earth. Most of that stuff, again, it's not going to be pulling content from some servers at a data center. It's going to be pulling generated content, uniquely generated content from the mainframe supercomputer in low Earth orbit.
Wow. That last part, I don't know when that can happen, when it takes all the electricity of this, of a weekend in Toronto for the whole city.
Yeah.
To
that was literally Bryce's first question when I asked. He's like, how it's going to get powered? But is there not enough solar power to do that?
No, not on the whole planet. Is there enough?
No, but you're in low Earth orbit.
Yeah,
you're not on.
But I mean, yeah, but you go put up like 20 square miles of panels to try to collect. No, I don't think the electricity works out. Now, if people will get back to being okay with nuclear, and you put some nuclear reactors in space.
Well, they're going to. That's absolutely throw a small modular reactor on a Starship satellite to power the supercomputer from NVIDIA that's on the backside of it.
If there's no risk when it deorbits, then then you're all good.
Theoretically,
First
there
part of
wouldn't
what you were
be, but
saying,
you might have a hard time convincing a lot of
But,
greens.
but back to the first part of which, I mean, the reason you would even talk about doing it is because you need your supercomputers in space. And it's like, you asked whether, are we coming full circle back to supercomputers? And I'm thinking, did they ever go away?
No.
Like, so
That's
we've
what data
always
centers
had,
were anyway, right?
Yeah.
what's that?
Data centers were supercomputers anyway.
Data centers were, and then, but so were supercomputers. I
Oh,
mean, so like data centers give you virtual supercomputers because you can treat them like a big supercomputer with however many of their virtual boxes you kind of have talking with each other. But there were actual supercomputers like Dojo kind of thing, or, you know, where they go and fill a large room with as many, you know, boards as they can, or, you know, this a hybrid of those where Google would take a shipping container and fill it with boards and then go like somewhere with a bunch of those shipping containers and just hook them all up without even taking the stuff out of the container, just deliver it as container and just be like, here's all this compute. So but the point is you need supercomputer compute for training the models. When you're trying to go and make GPT-5, GPT-6, et cetera, they take more and more power that, like, when they're working on GPT-7, we were all going to just see our lights dim. You know, so that's where, you know, on the other side of it though, like, okay, so we've trained it up and, but now most of what we want to do with the thing, we can do with just the inference that you're doing like at runtime. And that I can do on my Mac or on my phone. They're going like Claude came out with their, it's like Gemini and Claude both did this thing of having like 3 versions, small, medium, large, on their models. And it's like, I only need this piece of it, right? The stuff I work on, you know, we're mostly not dependent on OpenAI because we're using a lot of that retrieval augmented generation where you're pulling in the facts from your own company, from your clients' companies, the facts that OpenAI doesn't have. And you're incorporating that, and the stuff you're making is like more and more accurate because it's more like using GPT for being the common sense that ties things together. But when it comes down to answering questions and things, it's just not.
Yeah, I think, John, what Jensen was talking about just now, what I heard in part is that he thinks the next generation of AI applications and LLMs are going to be so big you can't do the inference on the device, and that he sees a new era of computing where it is all done in the cloud, on data center, on, you know, NVIDIA's massive high performance computing clusters. And then, you know, the phones do what the phones do, but the true next generation AI is done virtually, not on device. I think there's a difference of opinion there in the AI world of what that's going to look like. But I think that's Jensen's.
Yeah, here's what I don't get about that. Take whatever one, take OpenAI or something, right?
Mm-hmm.
They let's say they come out with the next version and it's so big and powerful and whatever. So you got 100 million people using it. So you're time slicing like crazy. How is it that having this one big thing that time slices by 100 million slices is, you know, going to solve the problem of, you know, what happens? I don't know.
Yeah, I see that.
John, I ask people in the space industry, and we're going to wrap this up in the next 3 to 5 minutes. We try to keep these around 30 to 40 minutes. I ask people in the space industry all the time, how long before we're sending people to Mars? And the answer is usually somewhere 10, maybe 20, sometimes 30 years out. I'm closer to 10 to 15 years. We'll see how it goes. How long before Optimus and or other humanoid robots are walking around, folding our laundry, being the school guard, crossing guard, driving school buses, helping build factories? How long before we've got humanoid robots using AI to actually provide services and time-saving efficiencies for the human race?
So first, to go back to your first part of that, because my answer was going to be Optimus, is, you know, going to Mars. I'm with the 10-year, 15-year time frame It's very, very, very far, but but not at being humans. Not at
Right. Sending
So-
robots, as Bryce explained in the Ultimate Tesla book. We picture the. Let me just grab the image here. We picture. I don't know why they have oxygen packs on the back, but the idea that it would be robots.
Battery packs.
Oh, battery packs. Okay, good. Yeah, those are battery packs.
ChatGPT
So-
made the image.
Yeah. So like, I think it's crazy to be a person and go to Mars until they've got, like, from my standpoint, I'll go like when they've got the malls set up there and it's like
When there's a
everything's
Texas
going-
Roadhouse,
Yeah,
then you're in.
McDonald's. Yeah, I'm in for that.
So anyway, that's what our robots are for, and they're getting so smart that we can send them to autonomously check the place out, set things up, go, okay, send some more of us over. The question will just be, by the time we get there, whether they let us in.
Papers,
That's on. So come back to Earth. How long before
Come back to Earth.
you've got a humanoid-like robot running around your house you bought for $25,000 and you license some software that enables it to work in an AI brain?
So for my sake, I sure hope it's in 10 years because I need it. I'm getting on there, and I'm going to need the help. And I'm seriously looking for that to happen. And I think that it's ambitious if we say 10 years. Just if I look at everything now, obviously you got this, everything increases so fast and whatever. I loved the recent, if you guys have seen the figure robot demo, it's standing there at the counter, and now it's got OpenAI on the brain, and it sits there kind of speaking in English to the guy, and hands him an apple and puts
it even says at one part.
Yeah, well, that's what it says to me when I'm on my phone.
right.
And it's the
I know
same
the same.
ChatGPT voice kind of thing.
People were like questioning that on Twitter, and I'm like, if you've ever used the phone feature on,
It
app,
literally,
it does the same
it's
thing.
built in to do that.
Right.
That's how it talks.
It makes us feel more at home talking to it. So
Yeah.
yes, John, continue. The figure
So
robot.
I would love for it to be 10 years. If I have the pessimist in me, or realist even, puts it longer than that.
For the
But
robot, for Optimus Robot?
Now, but I was going to say, but the other half of me, looks at these curves that we're in, and how, like, somebody, I forget who was quoted as saying, but it's like one of the biggest kind of shortcomings of mankind is our inability to actually get exponentiality. So this exponential curve, it can be happening and you still see a straight line in front of you. It's very hard to comprehend the notion of the speed up. And if I take away that, if I go, okay, I'm aware of my lacking in that area, then I see it happening faster.
3 to 5 years.
Let's see. Let's write it down.
I'm writing it down. John de Oliveira said, January 29th, 2027, I'll have my Optimus robot delivered.
I think Cody said that, but like, aren't you making a prediction for that?
Yeah, I think it'll be within 3 years that you will be able to put in your order for the Optimus robot and wait for the delivery. They'll start delivering Optimus robots to Pepsi at the Pepsi factory within 2 to 3 years.
One of my biggest things that makes me not think it'll be 3 years is government regulations. Like, you can get into a factory and go, okay, go file these stacks and stacks of paperwork about safety, about what you're doing for this or that. You can't do that with the individual person. And look how people are shooting their own Teslas. It's like, what are they going to do once they get a hold of the robot? So that's what the fear I get is from, like, interference from the government not letting people have them.
Republican Democrat regime is always my biggest problem.
Yes.
John, did you see the company Cognition AI and then their website building software called Devon?
Yeah, we talked about that last week, maybe, I thought, but yes.
Okay, I couldn't remember if we did or not, but I thought that, and then the Figure AI's robot were kind of the two big developments on the startup front in AI this last week. But I was actually more impressed with Cognition and its ability to just create a website from scratch based on a text prompt.
There's a lot of hype around it.
It's all true,
Yeah, there's a lot of hype around it. You know, with but first of all, when I first saw it, I was like, okay, now my job's gone too. But the more I see, the less I think it's going to take my job. But it's funny, people who say it won't take your job are like, oh, but it's just going to enable, you know, an extra X million number of people who couldn't do this to go and do it. Well, that's taking my job.
That's more competition. That drives my prices down. My salary goes lower if there's more competition.
Yeah. So anyway, it is pretty amazing. I think the biggest next step for Devin and things like it, one will be to open source something like that. The next will be to have it be more like in a cooperative loop with the developer. So it's not like push a button, go away for an hour and come back and see what it made for me, but be able to kind of work together. That's where that thing is going to really take off.
I have one point of cynicism and skepticism to make about Figure AI. The guy who created that company is the guy who created Archer Aviation. Archer Aviation is a publicly traded former SPAC. The stock has been absolutely demolished, and they've delivered an absolute zero things they said they would deliver. And
they're building autonomous electric vertical takeoff airplanes is what Archer
You talk about Brad.
they're grifting the people who want what you just described.
Yeah.
No, who's actually doing that now is the other, what's the guy's name?
Joby.
Was that?
Joby's doing it.
I was going to name the guy who created the Facebook bought the VR.
Oh, yeah. Oculus. That guy's the real deal, though. The Archer guy and Figure, which is now the Figure guy, I'm not a fan.
His name's
For the
Brad.
record, the guy who what's the guy's name who did the?
I'll look up the Optimus guy. We were talking about the Archer guy. His name is Brad Adcock.
No, the guy what do you call Oculus? Yeah.
Oculus. That's what
the Oculus guy. I think he is
Palmer Luckey.
Yeah, Palmer Luckey. I think he is Syndrome from The Incredibles. 0 point energy, and he's got the thing, and he's like, that's him.
And on that note, ladies and gentlemen, thank you for watching the AI Revolution with Cody Willard, Bryce Smith, and John Dio, also known as John D. Oliveira. I say it right?
Yeah.
I've known John for
30 years.
30 years now. Yeah. It's been a hell of a ride. Yeah. Anyway, thanks for being here, John. As always, your insights are second to none. We really appreciate you being able to walk us through some of this stuff and being able to bounce every week. We're like, oh, we'll have to ask John about that on Monday. Oh, yeah, Bryce, make a note. Don't forget we asked John about that on Monday. So thanks so much, man. Appreciate it. Thanks, everybody, for watching. Peace and love. We'll see you next Monday. Same bat channel, same AI place.
I would encourage everyone to go watch the recording of Jensen Huang's keynote from today. Pretty amazing stuff happening at NVIDIA, I think.
Yeah.
So
and go sign up at tradingwithcody.com. Yeah. Got to make some money. Come on. Peace and love. Thanks, everybody. Bye.
All right. See ya.